Today's video is going to be about standard deviation, but in order for us to find standard deviation, we do need to be able to calculate the mean as well. I imagine you have probably already covered the mean at some point in your past classes, but I did go ahead and put it on here just to briefly cover it. So looking at the mean first to begin with, the mean is just the average. The way you find the average is you take all of your data points, add them all up, and then divide by how many of them there are. Now once you have found the mean, then we will be able to find the standard deviation, which is what I actually want to talk about today. As the definition says here, standard deviation is a measure of how varied basically your data is. It's how much the values in your data set vary from the mean. So it's kind of a measure of distance. You could kind of think of it the same way as absolute value to some extent. You know, absolute value, what that really is a measurement of how far something is from zero. Standard deviation is kind of the same idea, except it's not from zero, it's from the mean, which would change based on each individual data set. So unlike absolute value, that's the same all the time, standard deviation is different depending on each individual set of data you may be given. In order to calculate your standard deviation, you basically have three steps here, which you can see here on the screen. The first thing you're going to do, and I will say this is a bit of a long process, but step one is you want to find the difference between every data point and the mean. So you want to take the mean minus the data point type idea. And then you are going to square all of those differences. And really you can take the data point minus the mean, or the mean minus the data point, doesn't really matter. But you're going to square those differences. The idea of that is you are squaring them because that way you don't have to worry about whether they are negative or positive. Because remember, any number squared gives you a positive answer. So everything is going to end up being a positive number once you're done squaring it. After you've done that, after you have found the difference from every single data point and the mean, and then you've squared all those answers, you're going to take all those squared differences and you're basically going to find the mean, the average of those. You're going to add up all those squared differences and divide by how many of them there were. After you have got that mean from your squared differences, you're going to square root, somewhat reverse that squaring process, and that will be your standard deviation. For an example, let's take a look at this set of data. This is the exact same set of data we used for our box and whisker plot video as well. We want to find the mean of this set of data to begin with. Now, it probably wouldn't hurt for you to pause this video and calculate the mean yourself so that you can check yourself with what I have, but that is on you. If we go about finding the mean for this set of data, the first thing we would want to do is add up all of these values to see what we get. Find the sum of all these values. If you do that, if you add all of these up, you should get 186. We then need to divide that sum total by how many data points we had here, which we had 16 data points if you count these up. We have 16 different numbers here. So we need to take 186 divided by 16. And if we do that, we will find that our mean is approximately 11.63. If we take 186 divided by 16, we get around 11.63. So now what we're going to do, and this is where the process gets long, we're going to take this mean of 11.63 and we are going to subtract, we are going to find the difference with every single data point, all 16 of them. After we find that difference, we're going to square it to get our actual number that we're looking to use. For example, I'm going to go from left to right, so I'd take 11.63, my mean, minus our data point, our first data point of 3. 11.63 minus 3 is 8.63. Now, I want to square that difference that we just found, and we would get 74.48. That is the first of 16 numbers that we need to find. So, meaning the next step would be to take 11.63 minus 4, the next data point, 11.63 minus 4 is 7.63 squared. Well, it's 7.63, and then we want to square that difference, which would give us 58.22. I would point out there are some repeated data points, so we do kind of already know that for our third data point of 4, we should just get the same 58.22, right? That much we can at least be certain of. But you want to do that for every single one of these data points and get all these differences squared. Alright, if you have done all of those differences and squared them, you should have a list that looks something like this probably. Feel free to pause this video and check these numbers first if you would like. But assuming that you were able to get all of these numbers correct, now we have all of our squared differences from our data points, so we want to find the mean of all of these numbers. We want to find the mean of all of these squared differences, meaning we need to add all of these up and then divide by 16 because that's how many points we have here. If you go add these up, again, feel free to pause the video and do that adding here, but if you add these up, you should get 637.8. So we need to take that then and divide it by 16, because again, that's how many data points we had there. That's how many squared differences we had, was 16. 637.8 divided by 16 is 39.8625. Please remember, because I know it's going to be hard, after all this work, you want that to be your final answer. That is not your final answer. We still need to sort of reverse the squaring that we did, and we need to square root this still to get our standard deviation. If you square root that 39.8625, you will get that our standard deviation is approximately equal to around 6.31. That would be your standard deviation for this.